Okay, today I want to continue with the GameBoy assembler. Our to-do is still quite long. We have implement parsing of all instructions, jump instructions and labels, directives, and all kind of other things, right? Making it a bit more robust. I actually thought about something which is kind of annoying. Implement a string type and back it with a buffer. With an arena buffer, actually. Allocate for kid first. Okay, just to explain, at the moment I'm taking the whole source code file into memory, right? And every label that I find, or every symbol name, is just a pointer into that file, right? But then I realized at some point I want to have include files, right? So allow include files slash file includes, however you want to name it. And I don't want to hold all those files in memory at all time, right? Roughly, I just want to hold one at a time in memory until it's done processing, and include files will be done processing, and then I go on back to the main file. So I want to free all that memory, right? Because like, why would I hold on to like, I don't know, 20 include files? That doesn't make any sense. So for that, I need kind of a backing buffer just for strings and a specific strings type. I have somewhat of an idea of how I want to do it, but it will take a bit of time, and well, I'm not going to do it now because it's a bit of a distraction from what our goal is from today. As a recap, these are the instructions we already implemented, right? We stopped with the RST instruction by reading out the index, which is quite cool. This gives us a good building block. And these are all the instructions that are left, which are a shit ton. Pardon my French. So let's continue with that, I would say. Close all this up. And I need a bit of a refresher with the source code because it has been a while. A few days, actually. So let's set this as the starting project. And yes, so let's familiarize ourselves with the project again. I have the main file. Let's see, where is the parsing actually being done? So we have get tokens from line. Also not quite happy how this works, but we'll see about that in the future. Then we have parse, GBA parse tokens, right, where we go through all the tokens, which is cool. Then we have the symbols. To do, temporary, remove me, right, because I implemented registers as well already. Well, isn't that cool? Okay, well, we look up the symbol by name. If we have a symbol that is of type operation, we're going to go to parse operation. Yep. We have all those different operations right here. And if we have RST, we're going to go on and parse the index. And the index is rather simple. We require a white space first. Then the next token should be a number. And then we just return it like so. Okay. Then the number should just be one character, right? We're checking that as well. And then we're actually trying to parse the number by just subtracting 30, well, hex 30 from it, which is in the ASCII range for numbers. And then we just check if the number is bigger than 7. And if it is an error. Okay. And then once we go out from here, we write this to the output file, and then we check the end of the line again. Fantastic. So we have numbers, we have symbols. Okay, cool. I actually forgot that we already implemented registers. That is quite cool. Let me go to the tokens. Nope, it wasn't in tokens. Was it in symbol? Operation, register. Yes. Okay. I remember I had this symbol info struct here. Operation type, register type, and what does that do? That is just the enum. Okay. So we do not really need two separate structs for this stuff, right? And actually, let's combine those because this will be quite annoying in the future. So we have the GBA symbol info struct. We can just name it like this, right? Symbol info. And then instead of GBA operation type or register type, what we can do is make this a union, right? An anonymous union. So this way it's one or the other. Then we don't need this stuff. We have to compute hash. We have insert. Cool, 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 cool. Right, and then here we just say this is the symbol info, and then we have, let's just call it known symbols, right? These are all known symbols. And then we can just add those like so. I mean, we can leave some comments here, like these are operations, and these things are registers. Okay, and then we can just say add known symbols now. We have the symbols table. We have our known symbols. Sorry, this is symbol info T. And then we have down here symbol info T from these symbols. GBA symbol info T. Oh man. No, now I screwed myself over. Shit. Okay, never mind. Should have thought about it a bit more. Let's revert. Abort mission. Yeah. This will take too much time to fix, so let's not get hung up on this one. Well, okay, well, we have registers, so that is good. We can say invalid operation on registers as well. This is just test code I had in here, so we can safely remove this. And let's see what kind of operation we actually want to implement, right? Jump instructions we won't do now, but I think a good thing to do would be increment without the indirect stuff for now, because that is a bit advanced. Yeah, let's do that. Okay, so ink. Where are you, ink? Ink is here. Okay, cool. So we can do a break. We'll probably have something similar to this right here, where we say instead of parse index, it will be parse register. And well, I do not know the result yet, the return value of it, but let's just do parse register, and then we need to do something to write it into the file. We'll figure out what we need to do there shortly. Okay, so parse index, and then we have bool GBA parse register with a GBA context T. Context, there we go. Okay, similar to the index, because it's an argument that starts, right, the next token needs to be a white space. And here we can say register operand is missing, right? And then we look for the next token, which shouldn't be a number, but rather GBA token type symbol. And if it is not a symbol, then the register operand is missing because it could be a number, right? And that is just plain wrong. Okay, now what do we need to do here? So we need to figure out, is the symbol an actual register, right? If it is it one of the registers that is allowed in this instruction? How we determine that, and if they're all kind of the same or not, we'll see. Most productive Tuesday to you too. So we need to figure out, is this one of the registers that is allowed in this instruction? And if that is all the case, we just need to return something. So at the moment, let's just return true. Okay, is this symbol an actual register? And now I have to refamiliarize myself with the code because I forgot what I coded to figure this out. GBA lookup symbol by name. Will you look at that? So we'll probably need to do something like this, right? Okay. Bam. Right, we can fetch the next token. Oh, no, we already fetched the next token. So we already have this, but we're extracting the symbol name out of it. So we have the input.data, then we have the token, which is the start position of that token. We have the symbol length, which is token end minus token start. Then we call GBA lookup symbol by name based on that symbol name and that symbol length, and we should get a symbol back. If we do not get a symbol back, then it is an unknown symbol. Is that fine, or should we say unknown register? Because we are in the register thing. So yeah, let's just say unknown register. And we return false. Then we check the symbol type. If the symbol type is a register, right? Validate register. Otherwise, we can say invalid register. Yep. And this will be returned false, while this will be returned true. And then we do not need a return down here because this is the end of our function anyways, the default branch right here. Okay. Now we need to validate the registers. So what kind of registers do we actually have? That was in symbols. Apologies, always need to figure this out. Okay, we have A, B, C, D, E, H, and L. B, C, D, E, H, L, A, F, and S, P. Okay, let's see. We have A right here. We have B, C, D, E, H, L. Okay. B, C, D, E, H, L, right? B, C, D, E, H, L, which is fantastic. And we have SP. We do not have AF. And this is something special, which is an indirect HL. Yeah, that one will be curious to figure out. Okay, where is AF actually used? Right? On push. So instead of SP, we have AF there. That's it, just in push. Okay, so we can have something special for push, so we do not need to use the same register stuff. And most of them, I think, are the same. Oh no, these don't allow register pairs. So we probably need something to disable pairs, but it seems indirect HL is always allowed. ABCDHL, yeah. Well, and ALD is like... LD is one of the worst ones to implement. I'll be upfront about that one. That one will be horrific. Yeah. I was already trying to think ahead, but it seems like we have to have multiple pass registers depending on what we want to do. But that's okay. So we have symbol, info, and reg would be the thing to look for. And here we want, well, basically these, right? Let me use Sublime for this because it's easier to edit stuff. Okay. Right, so, no. There we go. Case will be one of these, and well, I suppose I do need a break on all of them, right? So let's make it like so. Okay. So register type A, let's see. We can already follow a little bit of a pattern. So the register in the inc instruction, for example, as you can see, the first 2 bytes are always the same. So are the last 2 bytes, right? Okay, with the exception of down here. Let's ignore register pairs for now, right? But the middle part, as you can see, is actually 000, 01, 10, 11, 100, 101, and then interesting. So what we could do is something like this. Basically encode, I don't know why I pasted this back in, sorry about that. Basically we can encode these bits into the enumeration of the registers right here. So B would be, let's not do A for now, but B would be 0x0, right? And then C would be 1, D would be 2, right? And E, to no one's surprise, would be 3. This would probably be 4, and then we have 5, right? 5, right. And then we have 6, and then we have 7. Yeah, so A would be 7. No, let's just leave it here. Okay, so yeah, this is our enum. So basically, if it is any of these, it's really annoying that register pairs are the same. Oh, and 6 is indirect HL. So I'm trying to think whether indirect should be just symbol names as well that I just put in, right? Because they mostly have fixed value. It's mostly going to be indirect HL. Or it's going to be some number. I wonder if I should distinguish between register and register pair, right? Maybe that makes things easier. And then indirect should be another token, really. Well, okay. Let's go and add indirect tokens. GBA token indirect begin, right? Which will be this one. And then we have GBA token indirect end. Do I like the syntax of indirect? So do I want to type inc HL and just conform to the standard? Or do I do something like inc HL, which is like more close to C, right? Have the symbol here and get me the thing that HL is pointing to, which in end effect this is, right? So HL has an address, and instead of getting the value that is in HL, we're getting the value of whatever HL is pointing to, which I mean, right? So at least do not have to look for like an end character, which makes parsing a bit simpler. So what if we have, let's say, ink and then some name, or we have direct address, like so, or we can have a hex value, right? So it's that versus this, I don't know, some number. Well, actually not that long because it's just 16 bits, but whatever. I mean, it would be nice to conform to the standard, I suppose, right? So if we look at this hello world asm file that someone provided right here. Oh, see, this is where they already deviate anyways. They use square brackets. Right. Yeah, whatever. I just use the star. I like this better. So an indirection will be the star character. I don't think I use stars for anything else in this assembler, so this should be just fine. Okay, well, so end of line is still new line, right? Just going through all the functions right now to see if we need to account for this new token, which I'm sure we will. So end of white space could literally be anything. This is fine. But find next token character. So now we need to also add this one right here for indirections. And then get tokens from line. So if we have a comment, if we have a separator, yada, yada, yada. And we need to do the same with this one. So case indirect. Right, and that will be token tokens I type equals GBA token type. I haven't added the token type indirect yet. Is that correct? I didn't. Token type indirection. Indirection. Okay. If you're slightly dyslexic, writing is hard. GBA token indirect. Yeah, this is a token type for indirection. And then we have tokens I end equals, well, just the next one, really, right? So offset +1. Now, is there allowed to be white space in between? Not really. So in our input file, if we were to write something like this, right? It shouldn't be a thing. It should always be attached like so. But that is not for the tokenizer to validate. That is for the parser to validate, right? Here we just tokenize our stuff. So last check. No, this seems to be okay. Okay, now let's go to main. Get next tokens from line, then we pass the tokens. Yep. Okay, if we have GPA token type indirection. This is the first level of the file, right? We do not want to allow indirections here. So if a line starts with an indirection, something is wrong, right? So we should print that unexpected indirection pointer, expected operation instead. Cool. Then we have a number. Yeah, we say unexpected number. Then we have a symbol. We look up that symbol. It's an unknown symbol. If it is an operation, we do something with it. Otherwise, it's an invalid operation. Okay, cool. So that means we have to go into parse operation now. Those are all just these operations. That is fine. Parse end of line. Right, we want to add an error message here as well for indirection. So, right, unexpected indirection. Expected end of line instead. Yep. Cool. Then we have parse index, where we expect a white space and then something else. Okay, I think I have an idea of how to do this. We can split out these two in separate functions. So we want to check whether, so there's some operations that have optional arguments, right? Well, there's only just one, I think. I forgot which one. Ret. Oh, there we go. Return. So it can either have like some form of argument or it can't, right? So what we can check is, does it have a white space? If it has a white space, there probably is an argument there and we can check for it. If it doesn't have a white space, we can just leave it be. And we can do that with all the others as well. So bool GBI next token equals. Hey, thank you for the follow. So we can have something like an equals, where we just check for the next token type. So what do we want to pass in? Well, we need the context, obviously. And we want to pass in the token type that we want to check for. So GBA token type T. Nope. Gosh, what did I name it? GBA. Why did I have this uppercase? Naming consistency right here. Oh dear. Oh, I even did it in the same file. Good gosh, what was I thinking? Okay, you know what? Let's make this a to-do for later on. Consistent naming conventions. All right, I'll go through the file and fix all those names because that is ridiculous. This is what happens when you code over multiple days for just 3 hours or so. Okay, and we just want to type that we want to check for, right? Let's call this expected type. So then we can just plug this one out. We have a token. we get the next token. If there is no next token, then we just return false. And if the next token is not this one, we also return false. Oh, but then I want to retain that token, right? Oh, man. So really, I maybe should just fetch the token without advancing. Or I need to design this in a way where it actually returns a token. So hang on, the token is just a pointer, right? So really, this was nonsensical because the token is always there, right? I don't need to worry about this. So let's change this to GBA token T and return a pointer to that token instead. Right? We still advance, that is fine. But then we just say return the address of this one. Otherwise, return null. Okay. Let's ignore this one for now and just fix what I previously done. Oh, I hoisted this out of here. Not great. But then yeah, maybe I shouldn't advance in here. Maybe I shouldn't. Right. Let's see how that feels. So we're trying to see if the next token equals a specific type, right? And if it doesn't, that is an error. But then we still need to process that token. So we are going to parse end of line, which advances the token index anyways. Okay, that helps. Okay, yeah. So we have a token. We are getting that token. Actually, let's not squish this in one line. That's not nice. We're fetching it like so. We just have a token pointer. We get the next token. It no longer has this return value, right? And I hope I removed it. Yeah, cool. So, and if token is not null and token type equals expected type, then we can say return true. Otherwise, return false. But then really, if the next token is equal to what we're expecting, we kind of want to consume it and probably also return it, right? So then let's make this GBA and we can also copy this into this one, to be honest. Get next token if equals so we are fetching the next token and if it is indeed equal, then we want to increment the index for good and return the token. Otherwise, let's just return null. Okay. Can index only be in the first one? Let's see. Index. It's probably easier if I just search for number 7. Well, except I get into the ASCII range 7. Oh dear. Yeah, so bit 7, res 7, set 7. Okay, it can only be in the first one. Okay, so I can just leave that in here. So get next token if it equals, well, if it equals GBA token type white space, right? Because we're expecting a white space for an index. GBA token T. Well, but we not really need to consume it, so... So if this is not null, and token equals GBI get next token if equals numbers, and if this one is not null. Well, okay, this is my parcel. I apologize, I need to go for a quick break. I'll be right back. Sorry about that. Well, I'm back. Turns out it wasn't even the right parcel I was waiting for. It was a completely different one. Yay! Too bad. I thought I could do a little unboxing on stream, but okay. Right. Parse index. We're looking for a white space. If we have it, we continue. We get a next token. If it is a number, we get it. Otherwise, we're gonna say number operand is missing and return false. Right. Okay. Then we can still do the same thing with token start like this, invalid number, rare, yada yada yada, and write out the index. Okay. So parse index is all good, right? Now, register type. I think I really need to separate register groups from the other registers. So let's do that real quick, right? Type div enum GBA register pair type, and we're just gonna take these things out of here. Let's quickly check if there is any registers where we cannot use A. Although I highly doubt that. It would be really weird. Yeah, there's an A here. They all have A, I think. Load definitely has A. A. In case for those wondering, register A is the accumulator, which is, so if you do any math operation on the GameBoy CPU, it will store that number in register A. I know I wanted to explain how registers work, but let's be honest, I'll probably do this once I actually start coding something that runs on the GameBoy instead. Because otherwise this gets a bit too convoluted on stream. Okay. So we have register pair types. Let's call it register pair type T right here. And then we have different types. Luckily, the beauty of unions, so every enum is just an integer. And the beauty of unions is that even though you have 3 enums specified here, they all use int as the backing type, which means all 3 of them, instead of taking up 3 integer spaces, so 3 times 32 bits, it will just use 1 32-bit, because only one of these can be active at a time. I really like unions, in case that wasn't obvious. I think they're just great. Right, so we have register type or register pair type. Oh dear, now I need to do all this for register pair. Yeah, I really need to restructure this, but I'm not going to do this today on stream. Let's just hack this in. Register pair, right, register pair, and this is also register pair, right, and then down here we'll copy this const and have it for register pair, register pair, and we just need these, and this will be register pair type. I also probably need to rename them in the enum above. Right. Register pair, so we can remove the register pairs here, and then we go up here and rename all of these. This is a pair, 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 and pair. Ideally, what I want, I can probably just put it well, no, I can't put them in the same enum, I think. But I can certainly make this whole, you know, those known symbol tables here a lot easier by just, you know, having just one or something. I don't know. I'll figure it out. For now, it's a bit ugly, because now we need to not only call @GBA register symbols, but also have another one for register pair symbols, right? Which is just annoying. Whoops. Not a double underscore. GBA register pair symbols. Symbol type register pair, I suppose. Which we also need to add. And then this won't be OP. This will be pair. And I just realized this shouldn't be OP either. That was a bug. This should be reg. Right. How did that work? I mean, it does just work. I do not need separate enums, to be honest. I've overcomplicated this way too much. I mean, I have a symbol type right here, right? Symbol type register pair. Yeah, when you have the sudden realization that you overcomplicated something way too much. This already tells me what kind of type it is. Which means I could just have an int right here. And then just cast it to whatever I need if I want to have like the compiler check whether I used all of the switches or not. So God damn it. Okay, let's do it real quick. Int value, right, gone, no longer need a union. Then we have symbol info. Yeah, this is all still valid. This is all still fine. These enums can still exist. Okay, GBA register type. Register pair type. I'm changing the names as well right now while I'm at it. Why not? Because it is just enums after all, so we can just do this and this and this, right? Okay. Symbol name equals, that is still correct. Symbol table struct is also still correct, right? We do not need to change anything here, but we certainly can make these easier. So first of all, why are these typedef structs above the free function and the compute hash function and the insert function? They have nothing to do with it. Grow table as well. Lookup by symbol name. Sure, we still have that. GBA insert symbol by name. Yep. We do have that. That is correct. And then, so let's simplify this stuff. Let's call this known symbol struct, right? GBA known symbol T. So what does a known symbol have? Well, it has a name, it has an alternative name. That hasn't changed. But now it also needs the type, which is GBA symbol type. Right, so right here, type, and it also needs the value. Okay, so we can get rid of this, and then here, what do we know? We can make this a GBA known symbol T and just have this named known symbols. Okay, and then we just need to add the type, essentially. So we have GBA symbol type. No. No, it is symbol type register. Okay. Symbol type register. There we go. Then this can just be attached to that one, and that will be a symbol type of register pair. And a pairs. Another pair, another pair, another pair, another pair. Cool. And then last but not least, the operations, which will be register type operation. Coolio. And because I am extremely lazy, we do this and this. Actually, let's make it like so. Less ambiguity. And then we just say replace, 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 replace. Up to down here. And we missed one of them, but that is okay. Okay. Why are you white? What is this? Why are you freaking me out? Go yellow. There we go. Thank you very much. And then we can just say GBA add known symbols, because that's what it is. We're just having known symbols now that we need to add. So we have size of known symbols T and size of the array of known symbols. Then we iterate over all known symbols. Let's just name it known, right? And we're building our symbol info out of it, which means we have the type, which is known dot type. And then we have a value, which is known value. And then here, GBA insert symbol by name, where we insert by the known name. And then the same one, we also insert with the alternative name. So this way we have symbol info copied twice, but it's a relatively small type, so I do not really care. I mean, this is what? 64 bits. 64-bit machine, so it's right up ripe for optimizations. And then we do not need all of these functions. Cool, isn't that much better? We have successfully cleaned this shit up. Okay. And then at the very beginning, where we have called, where did we call it? Here, add known symbols. It's just one call instead of 3 that I would have done before. Cool, I like this a lot more. Right. So back to the issue at hand. Where did we leave off? In parse, I believe. We were trying to parse registers, except that's not quite right, is it? No, it is parse registers. But we can break this up a little bit somehow. So parse index is its own thing. We consider that one done. We won't be doing any refactoring on that one anymore, no matter how we restructure all of this. But it's just a matter of how we're dealing with registers. And for most operations, the first thing we want to check is, do we actually have a white space, right? Is the thing that we're trying to fetch actually there? And then we can continue. So I would say we can have a bool, GBA has white space. right? And then we have GBA context T, where we have the context. And then the thing that we're doing here, because we actually do not need to handle the white space at all. That is a nicer way to do this, but I don't want to do this for every single operation that I have. Anyways, if GBA next token if equals white space, and if it is not a white space, no, actually, if it is a white space, right, so I advanced if that is correct. Cool. Brain, don't fail me. Let's say if it is null, then we want to push an error. We need the line, which we get from the context, and then percentage s is missing. And percentage s will be w char t. Let's just say name for now. So name is missing, right? And then we have return true. So if we do not have a white space, we want this generic error message right here, and we can provide what the error message should be up here. So now, that is a simple, quick way to check whether an instruction has arguments or not. I see I need to adjust these parse operations and stuff, which I haven't done yet, so bear with me. Let's just not look at this for now. Actually, no, we should look at that, right? Because this needs to be done before we actually touch this thing. So let's do it that way. I apologize, I have not thought this thoroughly through. I was a bit too distracted with other things in the past few days, so I haven't had much time to think about it. So I'm thinking about this on stream, which can make this process a bit slow, but so we have parse operation, yeah. We have the output data, and then what we want to check is info value, but we can cast this value to a GBA operation type. Yep. Yeah, this is perfect. And this way the compiler should still complain if we not have a case for each of these, right? I hope so. Actually, let's just test it out, right? So if I do this and compile, it probably won't compile. Yeah, shit. But token is always initialized. What are you on about? If it is not null, wait. If this is null, or token is null, then we have this. Right, the compiler was absolutely right. I was just dead wrong. Huzzah. Okay, this is now correct. Unresolved. What? Parse operation. Parse register undefined. Yes, because, yeah, we do not have that anymore. Obviously, build. Did that work now? Different const qualifiers. Okay, we do not care about that stuff right now. I can just remove that const, whatever, it doesn't matter. Right. Are you happy about that? Okay, it seems the compiler is not warning though. Not in the way I was hoping it would. For this operations parsing right here, because I just removed LD. What if I do it this way? Value equals info, whoops, value. I mean, that cast is really unnecessary, but whatever. So what if I have this and we remove this one? Do I have a default in here? No, I don't. So that should just work. No? Okay. Oh, wow. Doesn't matter. We can do without. Okay, and my dog doesn't stop barking, so I have to quickly check on her. I'm sorry. Give me another 2 minutes or so. All right. Yeah, I should be back in 2 minutes. Well, I am back. Slightly earlier than intended. My dog seems to be really anxious today, so I have to spend some time with her in a bit. Let's see, how long did we already do? We did 1 hour, 30 minutes, roughly. So we can just continue a little bit further. Let's say 30 minutes and see how far we get for today. Okay, so we have all these operations. We have the index. That is cool. All of these, which are essentially done, right? Right, we're not doing this one now. So now, all these operations where we have the registers in before, they slightly follow a similar pattern, right? So I want to just implement a similar pattern like that. So these are subset instructions. Can probably deal with those today as well. And then maybe we can even get to the indexing part down there. And all of these are double. These are all singles. But ink and deck are somewhat special as opposed to the other ones here. Okay, slightly annoying. What would we name something like that? Should I just name it parse ink and deck? I think that makes sense, right? If I just group them like that. Ink and deck. And then these are like their own group. Together with the subset ones, I think. Why is there just pop 4? Where are the other pops? Huh? Did I screw up my table? Oh no! Oh no! There's no such thing as pop 4 anyways. Okay, fantastic. Right, let's do all the pops. And then no, like so. Hang on. Ah, okay, now. Right. And then all right, I deleted it. Okay. There we go. Those are the pops. What on earth was I doing? Yeah, those are the only... Yeah, it makes sense, right? Push and pop should be the same, so... Actually, push and pop are probably easier to implement right now. Let's just do that. So again, here, register pairs follow roughly the same structure, right? So BC in symbols, register pair, BC is 0x00, DE is 0x01. No, it is not. It is 2. Interesting. HL would be 4. and AF would be 4, 6. Yeah. But then SP will probably be the same. No, it isn't. Okay, well, hang on. 0, 2, 4, 6. It is the same. Okay, so I can't do it what I wanted to do with those two. Whatever. I'll explain in a second why I wanted these numbers here, because it's just so nice to add them then, but I'll explain in a sec. So okay, let's just do push and pop. Why not? That is easier. So we go to parse and make a bool and say GBA parse push and pop. So you get kind of an idea what I was trying to do down here and why I was struggling so much, because I want to group certain things together because they're parsed in exactly the same way. The only thing that changes is like the base instruction, meaning the first 2 bits and the last 3 bits, right? Everything else can be determined based on these things and then just shift it in. So what we want is a U8, which is the base, right? And then, actually we do not even need that because the shifting can be done on the outside, similar as we have done with parse index, where we just return the number that we then need to shift in. So let's just do that and call it register. No, we can't call it register because that is a keyword. Let's call it reg. No, let's call it operand. Naming, hooray! So, and then if we have to be honest, we can just copy the code up here. We might not even need this has white space right here, but hey, I already added it, whatever. Let's copy everything from parse index. So if the next token equals a white space, then we should check the token after that, and the token after that should be a register pair, because push only works in register pairs. And why are you not defined? Right, because it is a symbol. Right, this is something we need from down here. Okay, so then the next token should be a symbol. Really what we're looking for is a register pair is missing, right? Because push and pop only work in register pairs. And then we need to do the symbol resolving, which means we need the symbol name and the symbol length as we did down there. So input data token start. Yes, because we have the token here, right? Symbol length, token end, yada yada. Same stuff as before. Can probably make a macro for it, to be honest, to like simplify this a little bit. Then we look up the name, and then we say unknown register pair. That should really just be invalid register pair, but whatever. Right, and then we just have our switch. So switch symbol info dot type. So what kind of symbol type is it? Well, we are expecting a GBA symbol type register pair. Right. Can we have different? I mean, ideally we do want different error messages based on these things, I suppose. So let's just make cases for all of these. Why not? If I wouldn't try to like have different error message for everything, I assume the code would be much simpler, but I kind of want to be a bit more expressive with these things. So we have this default here, which is if it is a word, like a user-defined symbol, right? We can just say invalid register pair, yada yada. And then well, they're all just really invalid register pairs, so I'm not going to distinguish, whatever. This is for later. I mean, I have a to-do here already anyways, where I kind of, where is it? What is it? The to-do, rework how error handling works, right? So I'm going to worry about that later. Let's just get these operations done. So now we have a register pair, and now we can figure out what kind of register pair we have, right? So we can say symbol info.value, which will be a GBA register pair. No, that is not the name. Oh dear. No, not context. I don't want context. I want symbols. It's a register pair type. There we go. So we either have BC. To be fair, right, so we have the operand output, which right, so if it is this one, actually, I was thinking which way around I should do it, but those are really just the special cases. So if we have the AF one, it's a special case, or if we have register, just copy paste it, whatever. SP is a special case. Everything else, we can just say default, and then we can just set the output, so whatever operand is pointing to, and we can set that to this value right here. Right? Because these numbers here already translate to the right values for these registers. Only these two are special. Because, well, they have the same bit encoding, right? But we don't want to allow AF, for example, where we only allow SP, right? So they have the same encoding, but they have different names. So we kind of need to distinguish. So let's close this one. And only AF is allowed, right? So what we're doing here is then say operand is, and how is it encoded? With 4, 6, right? Okay, so 6. Yeah. Okay. And if it is SP, well, SP is not really allowed, so yeah, let's just say invalid register pair. Oh, I'm doing it down here as well, so might as well just leave that in the... No, I can't. This is a different default case, right? This is a different switch. Oh dear, oh dear, oh dear. Let's make that clear with something like this. Okay. I know switches and switches are not that great to read. Can be a bit confusing, but whatever. I sense a theme of me saying whatever. It's great. So we either have a register pair or something else. If it's something else, we just say invalid register pair. If it is especially a register pair type of SP, then this is an invalid register pair as well. If we have AF, that should just work fine. And if we have any of the other ones right here, which again, we're limited by this enum anyways, so unless, you know, we screw something up in the, where is it? In this one, in the known symbols table, but we don't. It's literally hard-coded in there. So no need for like overcomplicated error checks or anything like that. By that I mean default case could be anything else, right? And we would treat it as valid, which is not quite right, but whatever. Okay, so we have parse, push, and pop out of the way. That means we can add it right here. And the way we add this is, well, by simply saying parse, push, and pop. And if this fails, right, we pass in our context. And then we need the operand, which we do the same as down here where we have like index, right? Only this will be operand. So we can do something like this. And right. So this would be index. Well, needs to be the address of index. You know what? I'm probably going to use it more than once, right? Let's just call it, let's just, well, it's usually the destination, isn't it? Let's just call it destination and pass that in. And instead of index down here, we also use destination, right? So, and if this fails, we just return because we do not need to look for the end of the line, because something already went wrong, right? Our assumptions have not been met, so it is a definite error. So we're just gonna bail out, and otherwise we write to the output. So output offset, that is still correct. And this is now where we have to check our base. So this is for push, right? So push, where is my calculator? Push has an encoding of 1 1, and followed by 3 bits for the register, and then 101. So that is hex C5. So what we would write here is 0xC5. And then we have our destination that we just read out, and then we just shift it in, right, by 3 bits. Because we have this number essentially, we just need to shift it in. And we, of course, OR it, so we do not overwrite anything. Yeah. Cool, and then we can do the same thing for pop. There we go. Pop we also call just parse push and pop, because it is exactly the same arguments, doesn't really matter. The only thing that will be changing is our base right here, and the base for pop is 1 1 and then a bunch of zeros and then 0 0 1. So basically we just take this one away. So this is hex C1. There we go. Whoops. And this is push and pop. And now we can test push and pop if we like to. Let's first resolve some. Okay, index is undefined. Why is index undefined? Oh, right, because what? Why do I still have all this code in here? Okay, really what we want to do is return false here, right? And here on these, we just simply, well, if we haven't returned false in here, then we're going to be in here, so that means we can just return true. And then here we just return false. And then this becomes a non-issue. There we go. Much better. Rebuild again. Rebuild all succeeded. Okay, cool. So let's test it. Let's remove these. Right, the registers need to be gone for now. That was just a test, right? We probably want to make sure that all of these still work. I mean, we haven't really changed anything, but let's see. Line 1, yep. Line 2, yep. Line 3 is an error, yep. This is all valid. Line 8, yeah, the number operand is missing, right? So is it on line 9? Line 10, invalid number, yep. Line 11, invalid number, yep. Line 12, number operand missing. Well, technically not, but we need to adjust our numbers later on. We get to that. Then we have invalid index 8 on line 22, which is correct, right? Invalid index 9, and then number operand is missing again. Okay, but now we want to test that with push and pop. So all register pairs are allowed except SP. So let's just start with a valid one. Push BC, pop BC. Actually, let's remove all of that because we want to take a look at the output file as well. So let's do only push for now. BC, DE, HL, and SP is allowed, right? So. No. Hang on. AF is allowed. Well, we just tested SP, so SP is definitely not working, which is good news. But what we also probably want is push in lowercase bc. Actually, all in lowercase. Let's do it that way. DE push HL and push S. Well, let's do AF. Right, so those things work. Let's look at the output file. No, not LibreOffice. Jeez. No, go away. I want this one. And what do I want to open? GB assembler. No, what did I specify as the output again? I know I hard-coded it. What? Down here. Oh, Sublime, GameBoy assembly, output GB. Okay, fine. That will be Sublime, GameBoy assembly, output GB. Cool. Let's see if we are correct. GB instructions. This is what I wanted. So we have push, right? So with push BC, we have C5, C5. Cool, works. Then push DE should be D5, 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 exactly. Push HL, E5, E5, and push AF, F5, F5. Cool. Those work fine. So error conditions. Push SP, that's a no-go. Push SP is a no-go. Just push is a no-no. Push with a white space, equally a no-no. Right? We can have a comment back there just to make sure this is what we're testing. Right? Although, let's just do push as well. And then what also doesn't work is just register names, right? So A doesn't work, B doesn't work. Push with a bunch of white spaces definitely works. So if I make this an AF now, this should just pass. So line 11 should show up in the errors. What else? Let's make push followed by another push. Why not? We have fun like that, right? Then we have push, followed by push, push, push. And then push, what else? Well, let's just do a number, right? How about an index? Something like that. Whatever. Cool. And now let's check the arrows. So line and 2, invalid register pair SP. Exactly. Line 3 to line 8. 3, 4, 5, 6, 7, 8. Yeah, register pair is missing. Then we have invalid register pair A, invalid register pair B, invalid register pair push, right? And the same here, push, push. As you can see, we just check the first one and ignore the other ones. And then for numbers, we have register pair is missing. Why do we have register pairs missing? Because we already check if it is a symbol or not. Whatever. This falls under the category of like better errors, right? It's just important that we fail this for now. Whether the error message is correct or not doesn't really matter right now. Let's just get this out and done. Okay, now we need to test the same thing for pop, right? We have pop BC, DE, and HL, right? Okay, just have to check on the dock real quick. Then pop AF, whoops, pop AF. Although we can do it this way around, doesn't really matter, right? You can have either capitalization, it just works. Right, so this should just work. And indeed it does. And we check the outputs and compare with our document right here. Whoop. That is the output. So C1, C1, right? D1, D1, E1, E1, F1, F1. Fantastic. We just implemented push instructions. And pop. Cool. Whoops. I mean, we can test errors real quick, sure, but that will just be the same thing. So SP should fail, SP should fail, 15 should fail, right? Nothing should fail, nothing should fail. Tests, tests. Then we have pop with a bunch of white space. Oh my god, pop with a bunch of white space, but actually something valid, right? So line number 9 should not show up. Pop lala, pop ink. Yeah, that's pretty much it, right? That will just work as well because it's just the same function. So I'm not too bothered in actually testing this out because it's just the same thing, right? We already tested it just with a different keyword, but whatever. Okay. How are we in time? Let's see, I'm not happy that the only thing that I managed to do today is just push and pop. So I might be extending for just a tiny bit and get something else done as well. Okay. So I will not touch returns or jump instructions just yet because those are their own kind of insanity, basically. I mean, this is fairly simple. Right? Yeah, I think that would be okay. So I don't want to touch these right now because they have indirection and also immediates, right? There's some trickery to them. Int and dec also, I mean, we could technically implement these stuff, but the increment is probably too much for today. The indirection, sorry. I mean, these all have indirections as well, but I mean, we have to do it, right? So, yeah, let's do those. Okay, come on, we can do this. So another function. Hey, thank you for the follow. GBA parse, let's say bit subset. I'll explain why subset in a second. Let me just type this out. Context T, context, right? And then we have a U8 operand as well. Similar thing. And now let's just copy all of that down in here and refactor it to our needs. And we can probably get rid of this one. Cool. Right, so why a subset? So any of these instructions, as you see, they kind of clash with, you know, other OP codes that are up here, right? So for example, we have 0, 0, 0, you know, a whole bunch of zeros and then a 1, which is LDBC. But then down here, we are claiming that 0, 0, 0, a whole bunch of zeros, 1 is RLC. Like what's going on here, right? So this is subset instructions that are preceded by a very specific byte, as you can see right here. So if we encounter a CB, right, then the GameBoy processor will basically read this CB, will recognize it now has to read a subset instruction, which means it will read the next byte in the stream, which will be one of these, and then interpret those codes differently. So as opposed to interpreting this byte right here as an LD, it will interpret it as an RLC. Now, that means you effectively increase the cycle time because now it has to read 2 bytes instead of 1, although with this undeal instruction, as you can see, it is 3 cycles because like there's a bunch of arguments here, so it needs to read a bit more, but anyways, that's how you can think about the subset stuff. Will you switch to Linux in the future? I don't think so. So, first of all, I don't have Linux installed anywhere, right? It's not an operating system I use. I have Mac on one hand and a Windows machine on this side. And at the moment, I just want to focus on Windows programming. Because my goal is to like kind of learn, you know, I'm not even trying to use the C runtime at the moment. I'm trying to kind of, you know, wiggle my way around it. Thank you for the follow. So I'm not even, I mean, I'm using C runtime obviously in a few instances still, like fwprintf and things like that, but a lot of the file reading and stuff like that I have implemented with just Windows APIs, essentially. And yeah, I basically want to, at some point, strip out the C runtime and just have a Windows application. See, I don't think it's that much simpler, to be honest. Windows is relatively simple as well. So, I mean, anywhere the C runtime, if you just target the C runtime, it's easy to develop anywhere because every C runtime needs to implement the same thing, right? But on Windows, on Linux, for example, I don't even know, like, if I don't want to use the C runtime, how do I figure out, you know, which window managing system is installed, like what kind of APIs do I need to use and all this stuff. I have no idea about Linux in this regard. And I want to do some UI applications later on. So I'll just be focusing on Win32. So if you're looking for Linux content, this is not the place to be, I'm sorry. I mean, I never want to say never, but probably not gonna happen. Hey, nothing against Linus. Okay, I got a bit distracted, so let's parse the subset. Basically what we want is looking for registers, right? Or an indirection. So now, so GBA get next token if equals. We're still looking for the white space, which is correct. But now here, get next token if equals, well, we're looking for like different kinds of tokens, right? There might be an indirection. So really what we should say is leave this alone, right? So if there is no white space, then register is missing. Register, nah, operand is missing. Now our operand is either a symbol or an indirection. So it would be best to just first search for the indirection, I suppose. So if GBI get next token if equals context, and then GBA token type indirection. So if we have an indirection, we need to look for the symbol name. So really, I mean, we need to look for the symbol name in general. So what we can do is just have a flag, right? So let's say bool is indirection. And then we can just say this, right? So if it is an indirection, we consume it and set the flag to true. If it is not an indirection, we do not consume it and set the flag to false, right? And now we just continue with reading out the symbol. So in that instance, we need to look for a token. Hang on, we do not need the token up there. Let's just move it down. So we do it this way, and then we have, whoops, this stuff. Okay, we are looking for a symbol. Yep. Now, if token is null, the symbol is not there, so we're gonna report this little error up here. Operand is missing. Right, then we have symbol name, symbol length. We look up the symbol again, and unknown register, right? We do not care if it is a register pair for now or not. We just need a symbol. And then we have two cases. GBA, what did I, symbol type, right. It's just easy to type. So we have a GBA symbol type register. If we are a register, let me just check. A, B, C, D, E, H, L. We have A, B, C, D, E, H, L. So it can just be any one of these. Doesn't really matter. And let's see if the numbers are still correct, right? So B is 0, correct. C is 1, correct. D is 2, correct. E is 3, correct. H is 4 and L is 5. That is correct. And then we have A, which is 7 up here. Okay. and then 6 would be HL in the indirection, but we do not care about that. Okay, so we have a register, then all we need to do is return that one. So this is gonna be whatever operand is pointing to, and we will be setting that to symbol info value. Huh, will you look at that? Quite easy, quite concise. The odd one out is now the indirection. So, oh, yes, but if is indirection, right, then something went wrong. Invalid register pair. Even if we post a register, if we are in indirection mode, we expect a register pair. Specifically, we expect HL, right? And so that would be return false. And if we are not in indirection, we can just say, all right, set the operand to whatever the value of the symbol is, and then return true. Now, if we have a register pair, and if we are not in indirection mode, then that is also a failure. And then we just say invalid register because we just expected a single register and not a register pair. Okay, then we have the register pair type, and we're looking for one specific type, right? We're looking for HL. Everything else is a no-no. Okay, so here we would say return false. Do we have a break there? Why do I have a break there? Do I care about the break there? Sure. So we have HL. HL is indeed 6, right? And then the default down here. Okay, let's do that. I don't like this return down here. Whatever. And otherwise, it's an invalid register pair because all the other register pairs are not recognized for this particular command. Okay. Now, I believe that to be correct. Famous last words. So now, GBA parse bits subset. RLC is one of those. So let's look for RLC, which is down here. So if this fails, then we just return. Nope, it doesn't have a thingy. Okay. Otherwise, we're going to write to the output as usual. So parse bit subset, what do we write? We have the context, right? And then we have our operand, which we have right here. That is the destination. We need the address of it. And then, right, the base code for this one is all zeros. And then we just OR in the destination. We do not need to shift here because the register is up front right here, right? Even for HL, so that should just work. Same goes for this. Yeah, but we also need to write the preceding bit, which is this one, to indicate that we're in a subset, right? So this will be 0xCB. Okay, so that is RLC. Then we have the same for RRC. Went a bit too far ahead. Okay, so we have RRC, so we can just copy this in here. And what is that? That is a base of, what is this? 0.8. Cool. Then we have RL, which was up here. And that has a base of 10. Hex 10, that is. Okay. Then we have RR. Yep. RR right here. And that has 18. SLA, that is 20. SRA, sweet, 28. 28. And then swap, which is 30. SRL, which is 38. Now, and because we're doing pretty much the same thing for all of these, right? We probably could come up with like, you know, a little function where we group these together and just change the base number depending on which one we're calling. Maybe not a bad idea. I mean, we could also switch the writing into this one. But that's for later. Let's just go ahead with it. So then we have a whole bunch of other bit instructions, but those have 2 arguments, so I'm not going to deal with them yet. But we just implemented a whole chunk of things, right? Which is pretty cool. And all of these are also 2 instructions, and these, well, I could do the same for OR now, or CP or XOR, these kind of stuff, but as I said, there is also this immediate 8-bit, which is like throughout all of them. So probably these 2 groups will be a separate function. These will all be a separate function. Yeah, let's not talk about these. And then all the adds and stuff probably as well. Those are way more complicated. Okay, time to test, I suppose. There's a whole bunch to test. Okay, how about we copy this, right, and put that in the file right here. And then what we can do is a bit of magic. Chip. And then we just say chip, chip, chip. No, let's just, there we go. Whatever. Okay, I'm not gonna bother with like lowercase and stuff like that because that definitely works. It's just the same symbols. I mean, I suppose I should test it at some point, but let's focus on uppercase now for now, and then. Okay. Indirection does not work. So these seem to be doing okay. But all the indirections one don't work. Now, why is that the case? Let's see. What did I screw up? Check for the white space. Right. Then. Ah, right. Ah, man, because I have a different syntax, don't I? I decided to have indirections like this. Right. It's gonna be a star. Cool. Oh. Did I? Oh, shoot. I screwed up the editing. Apologies. Yep. Okay. What? Huh? 6-1. What is 6-1? Swap. Oh, because I deleted the L. Well, I guess we know that is working now. Cool! Okay, now we can actually look through all of these and see what happens. And immediately what we're seeing is they all are preceded by CB, which is exactly what we want. So, right. CB, 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 CB. Nice. Cool. Followed by 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Indeed. Then we have 8 to F. 8, 9, A, B, C, D, E, F. Cool. 10 to 17. Then just 18 to 1F. A, B, C, D, E, F. Correct. 20 to 27, right? 28 to F. And then we have the same with 30. Uh-oh. What happened here? SRL. Did I screw up SRL? Indeed, I did. SRL has a base code of 38. Well, good thing we checked. Nice. Okay, and then 3.8 to 3F. Fantastic. Now I feel a bit better. We actually have managed a few subset instructions, which is cool. So we're just gonna plop them down here. And what we're gonna say is this is preceded by Cool. Oh, this is looking better. So, I mean, there's still a shit ton left to do, right? I think the next one I will be doing are those other subset instructions, right? So where we just have to pass the bit, which we already have get index for, which is nice. So we can already figure that one out. Can probably just copy the code. And then we have the exact same thing with the registers, except it is the second operand, right? Which means we'll need to figure out how to deal with commas and white spaces again. Actually, we're just looking for commas. White spaces are optional, so we kind of need to skip them as well. That is an optional thing. But yeah, it's looking good. And then once we sort of, I mean, this is why I like to do it this way, because now you kind of see patterns emerging, and then it's like easier to refactor. Just, I like to do the dumbest thing first, right? Just get the dumbest thing out of the way, and then you see patterns emerging, and then you can just combine things, and then you can figure out how to do better error messaging and all this kind of stuff later on. Unless, you see something where it's like immediately obvious that you could simplify a lot, and then you should just do it. In this case, this is not really a simplification if I put this out in a different method or function right now. It could be later on, but for now it doesn't really matter. Okay. I think that's it. Let me think. Actually, you know what? While we're here, let me quickly check if my parcel is on the way. Because I was still hoping for an unboxing on stream. Let's see. Come on, where's the tracking number? I had you before. Why is this so difficult now? Oh well. It seems my parcel is stuck at the airport and it has been delayed. Well, no luck. That's for tomorrow then. I'm not going to say what I ordered, but let's just say it obviously has to do with the GameBoy. So, and coming fresh from Japan. But this is it for today. Thank you for watching, and I'll see you around.